Hello all. In this video, I'm going to discuss with you the concept of elementary transformation. So elementary transformation basically plays an important role in many matrix algebra, such as finding the inverse of matrix and solving simultaneous linear equations. So the matrix on which elementary operations can be performed is known as elementary matrix. So basically, if we talk about the transformation, so there are two types of transformation. First is row transformation and second is column transformation. And ultimately, these two transformations can be further categorized into six transformations. That is, three types of row transformation and three types of column transformation. And it includes interchange of two rows or two columns, multiplication of element of any row or column by non-zero number, and the third one is addition to the element of any row or column by the corresponding elements of any other row or column which are multiplied by non-zero number. Right? So these transformations basically are necessary to find out the inverse of a matrix. Now let's understand what the first transformation says. The first transformation is interchange of any two rows and columns, which means two kind of transformation can be applied. That is, the first one is interchange in any two rows and second one is the interchange between any two columns. Now let's see what does this mean. Suppose there is a matrix with element 1, 2, 3 with the first row and 8, 0, 6 with the second row. Now first transformation says that interchange of any two rows or any two columns. So it can be done in the manner, suppose we transform first row to third row. And what does this signs, the arrow here means it shows that interchange. This is the sign of interchange. Basically, it means that you are interchanging row 1 with row 3. But you can see that in a given matrix, row 3 is not given. So which means that this transformation is not correct, right? So we can go for another option, like we can interchange, we can go for the transformation between row 1 and row 2. That is, row 1 is interchanged with row 2. Now, is it correct? We have to see this. So we can say, yes, there are two rows. So this transformation is correct. This means that instead of taking row 1, I will take the elements of row 2, and instead of taking the elements of row 2, I will take the elements of row 1. So interchange here means that row 1 is changed with a row 2 and the elements of row 2 are changed with the elements of row 1. Now what we will get in the result? So we can form a new matrix with this transformation, and that new matrix is termed as resultant matrix. So the elements of resultant matrices are 8, 0, 6 with the first row and 1, 2, 3 with the second row. Now what we have done? We have interchanged the two rows with each other. Okay. Now the concept is why we are studying these things. Because we know that these concepts are helpful in the calculation of inverse. Now, if I don't want to apply this transformation, I can go for column transformation also. In the same example, I can transform first column with another column, or the second column with the third one, or the third column with the first one. So this kind of transformation can be possible. Now moving toward the second elementary transformation, it says that multiplication of element of any row or column by non-zero number. So here non-zero is what? It can be anything. It can be any scalar quantity. Like we can say it is 1, 2, k, m or any other thing. But point here is that it should be non-zero. That is not equals to 0. So one thing you must understand that whenever matrix can be formed, it can be any matrix. It can be a square matrix, or it can be rectangular matrix, or it can be a diagonal matrix, and so on. So here we will take an example of a matrix which includes 2 rows and 3 columns. Okay. So now what the property says, that any row or column is multiplied by the element which is non-zero. Now suppose we go for the transformation, and I will do this transformation, that R2 is transformed into 1 by 2 R2. What does this mean? Here 1 by 2 is a scalar quantity, and I can interchange the row by dividing each and every element of the row with 1 by 2. So what will be the result? We can see here that the transformation can only take place in second row. So the resultant matrix is, the first row will remain same because no change has been there took place in the first row. I am only changing the elements of second row. So the first row will remain same, that is 1, 2 and 3. Now what are the elements of second row? That is 8 divided by 2, 0 divided by 2 and 6 divided by 2. So what I will get? This is 4, 0 and 3. So ultimately in this way I will form a new matrix. So I will get the elements in this form of 1, 2, 3 and 4, 0, 3. In the same way, I can go for the column transformation. Now let's move toward the third transformation, that is addition to the element of any row or column by the corresponding element of any other row or column which are multiplied by a non-zero number. Now it includes three things. First is addition, second is multiplication, and third is non-zero number, right? So if we talk about this matrix, I have taken a square matrix of 2 by 2 so that it would be easier to explain the concept, and you will understand the concept in a more easier way. So here a matrix is given which includes 5, 3, 2 and 5. These are the elements which comprises of 2 rows and 2 columns. Now see here, we can go for row transformation also, and we can go for column transformation also. So here we see that if I go for row transformation and I interchange second row. So you can see here that second row is transformed into R2, that is second row, plus 4R1, means 4 multiply the elements of R1, that is row 1. So here we have addition, multiplication and non-zero. Right? Addition means the elements of two rows are added. Multiplication means elements of one row is multiplied with a non-zero number, that is 4. Okay, so this is what the property states. So what I will get? So you can see here that the resultant matrix will be, the first row will remain same, 5 and 3. Why? Because no such interchange has been taken place in that row. So what are the elements of row 2? So if you see here that the first element of row 2, that is A21, is 2. So it is to be added in 4 into the element of row 1, that is 5. That between 4 into A11, that is 4 into 5 plus 2. What I will get? I will get 22. In the same way, the second element of second row will be 17. Now how I will get this? 5 plus 3 into 4. Right? So I will get 17. So this is my resultant matrix. Now if I go for the column transformation, let's take the same concept, that elements of column 1 plus 4 times the element of column 2. So what I will get? In this case, the elements of column 2 will remain same, that is 3 and 5. As the change can take place in only the elements of column 1. So what I will get? 5, the first element of column 1 is 5. So 5 plus 4 times the first element of column 2, that is 4 into 3 plus 5. So I will get 17. In the same way, if we talk about the second element of column 1, it is 2. And second element of column 2 is 5. So 2 plus 4 into 5. So I will get 22. So this is my resultant matrix in case of column transformation. Now let us study the concept of this transformation with the help of a practical example. So now you can see in this example that there are There is a matrix of order, you can say 3 by 3, because there are 3 rows and 3 columns, and the elements of first row are x minus 1, 2x minus 3 and 1. Elements of second row are x minus 3, 2x minus 1 and 2, and elements of third row are x minus 5, 2x minus 5 and 3. Now you can see here this matrix seems to be very complicated. And what we have to prove? We have to prove that left hand side is equals to right hand side. That is equals to 0. So if I have to calculate the determinant by using the simple method of determinants which I have discussed with you in the earlier sessions, so it would be quite difficult for us to perform the mathematical calculations. So in order to do it in simplified way, I will go for elementary transformations. So if I have to go for elementary transformation, then we can see here that the column 1 and column 2, the element seems to be quite technical, right? But the elements of column 3, they are quite given in a simplified form, like they are given as 1, 2 and 3. So in this case, if I go for row or column transformation, through which I will able to get the element of 0 instead of this 2, and element of 0 instead of this 3. So in this way, I will able to get the determinant in a very simplified way. One thing I want to share with you here, that as while performing the elementary transformation, there is no such clear-cut formula to solve the questions, but we have to apply various transformations, like I have discussed with you the 3 or 6 transformations in the earlier presentation, through which we will able to get the calculations or solve the question in a simplified way. Okay, so here in this, if I want to make the element of third column as 0, so I will go for row transformation. I have two options, or I can say I have two, you can say, ways, right? So first of all, I will make some changes in row number 2. So what I will do, if I will deduct the elements of row 1, which is multiplied with the 2 from row 2, from the elements of row 2. So in this case, what I will get, if you see the last A13, last element of first row, this is 1. If I multiply it with 2 and then deduct it from 2, then I will get 0 value, right? Let me solve it for you, right? If I have the element of row 2, they are x minus 3, right? And I have 2x minus 1, and the third element is 2. And if I multiply the element of row 1 with 2, what I will get? I will get 2x minus 2, then 4x minus 6 and 2. And what I have to do? I have to deduct this thing. So what I will get? I will get x minus 2x. I will get minus x, right? And it will become plus 3 minus 3 plus 2. I will get minus 1. Okay. Here I will get 2x minus 4x as minus 2x, and minus 1 plus 5 as plus 5, and 2 minus 2 as 0. So the new row which I formed here with the help of transformation is minus x minus 1, minus 2x plus 5 and 0. In the same way, if I go for the transformation of third row, what I will do, elements of my third row minus 3 into elements of my first row. So again I will write my elements of third row as x minus 5, 2x minus 5 and 3. And what are the elements of first row? It's x minus 1. When I have to multiply it with 3, I will get 3x minus 3, 6x minus 9 and 3. Now I have to go for subtraction. So I will get x minus 3x is minus 2x, minus 5 plus 3, that is minus 2, 2x minus 6x as minus 4x, and minus 5 plus 9 as plus 4, and 3 minus 3 gives me 0. So this is my new row 3. So what is my resultant matrix on the basis of these rows? My resultant matrix is, you can see here, my first row will remain as it is, right? There is no change in the elements of first row, so it will remain as it is. This is x minus 1, 2x minus 3 and 1. And instead of this second row, I will get a new row. So I will write here as minus x minus 1, minus 2x plus 5 and 0. And my new third row is minus 2x minus 2, minus 4x plus 4 and 0. So this is my resultant matrix, right? So if you remember the property of matrix, so here it is clearly given that whenever we have to calculate the determinant, then we can go for any row or we can go for any column. The value of determinant will remain same. Okay, so here in this matrix, if you see, then first column and first row, this seems to be quite complicated. So I will go for the value in order to calculate the value of determinant. I will take this third column, right? So you all know this thing that we have to write here plus, minus, plus, minus, plus, minus, plus, minus and plus. So this I have already told you, right? So whenever I have to calculate the value of determinant, so I will go with this column, that is column third, okay? Because the values are simple, so I will write here as plus 1, minus 0 and plus 0, okay? So if I will write here 1, it means that I am not supposed to take the elements of first row and third column in which this one element lies, okay? So this is my value comes under A13. This is my A13 element, means I'm not supposed to take the elements of first row and third column. So whatever is left, I will take it as minus x minus 1, minus 2x minus 2. Here I will get minus 2x plus 5 and minus 4x plus 4. Okay, so in this way I will make this submatrix. And if I have to take this A0, which is A23, so whatever values I will take here, so ultimately when these values, the result of these values is multiplied with 0, I will get the answer as 0. So there is no need to take these values. Okay, so I will move further to the next step. So in this we have to go for cross multiply in order to solve the question. So what I will do right here, I will write plus 1 and I will expand it, I will solve this. I will get minus x minus 1 multiply with minus 4x plus 4, okay, and minus 2x minus 2 and minus 2x plus 5 and plus 0, okay. So this I will get, okay. So now I will solve this. I will write here 1 into minus x into minus 4x, I will get 4x here, and next is minus x into 4, I will get minus 4x, minus 1 minus 4x, I will get plus 4x, and minus 1 plus 4, I will get minus 4. So minus 2x into minus 2x, it's give me 4x square, and here we have minus sign, so I will write here as minus 4x square. Then minus 2 into minus 2x. Okay, this minus 2 into minus 2x, it will give me 4x, but here we have minus sign, so I will write here minus 4x. Minus 2x into 5, so minus 10x, but outside the bracket we have minus sign, so I will write here as plus 10x, and minus 2 into 5, it gives me minus 10, and this minus, if I will take into consideration, so I will get plus 10, and this is equals to 0, right? Because here the matrix in the question, this is equals to 0. So what I will do next, I will write here, this 4x is cancelled, right? And next we have 4x square minus 4x square, again it is cancelled. So I will get minus 4x plus 10x. This gives me 6x. And here I have minus 4 plus 10. So I will get plus 6. So this is equals to 0. So what I will get? 6x is equals to 0 minus 6. Okay, so this will give me 6x is equals to minus 6. So I will get answer as minus 6 divided by 6. So the value of x here is minus 1. So this is my solution. So now you can see that with the help of elementary operations, we will be able to calculate and solve the question in a very simple way. Hope the concept is clear to you. Thank you very much.